I'm Len Vermillion, editor-in-chief of Control Global, which you know includes Control Magazine. And this month, we're talking to the newest class of the Process Automation Hall of Fame. Now in its 26th year, the Hall of Fame features some of the most notable practitioners and educators of process control. And now there are a few new members. Today, we're going to talk with one of those new members, Manfred Morari, who is professor of electrical and systems engineering at the University of Pennsylvania. And as some of you probably know, he's done some really interesting research and work in model predictive control, which we're going to talk about in just a bit. But first, Manfred, let me congratulate you on being voted into the Hall of Fame, which, of course, is nominated and selected by the existing members. So, how does it feel to receive this honor?
Len, when I got your email, I was surprised. And when I looked through the list of past awardees, I was humbled because about 30 of them I know very well.
Mhm.
And over the years, I've valued their technical contribution and their professional advice.
Wonderful. You're right. So I'm sure they want to hear about you. We all want to hear about you, and we'll hear your story. So why don't we go all the way back and start at the beginning, so to speak? So you grew up in Graz, Austria. I hope I pronounced that correctly. So what made you interested in engineering in general and led you to start studying it?
Then that's the answer is pretty simple.
Hmm.
I was inspired by my high school chemistry teacher.
Okay.
And he also taught me physics and mathematics, and so he had a big impact on my thinking and my taste.
Okay. Yeah, that's wonderful. I know teachers definitely inspire people. And so you ended up studying chemical engineering at ETH in Switzerland, and then you came to the States for graduate studies later. So, why don't we talk a little bit about, your time in ETH and how did you choose the University of Minnesota for your grad work?
Yes, actually, from today's perspective, it probably sounds complicated.
Hmm.
And at that time, it was complicated because when I was about to make my choice about graduate school, um, that was 1974.
Hmm.
Uh, the means of communication between Europe, Switzerland, and the US were very limited. A phone call was expensive. Obviously, anything video was totally out of question. So everything was by mail,
Hmm.
and so I had very little information to go on choosing a department for graduate school, and um, the only facts then that I knew about Minnesota was what people on the street are talking about, namely that Minnesota is very cold.
Hmm.
And the other thing is that was in some Time magazine article of that time that the state bird in Minnesota was the mosquito.
That's
Um, so this was not enough to decide on graduate school, but I was very lucky
Mhm.
that at ETH, one of the senior researchers whom I met at one of the exercise sessions, one of those researchers, his name was Rex Reed. He had received his PhD in chemical engineering from the University of Minnesota. And he somehow made it his mission to convince me to go to Minnesota for graduate school. And I would say, fortunately, he succeeded.
Mhm.
And I was forever grateful to him for pointing me in this direction, obviously giving me letters of recommendations and so on.
Wonderful. So at the beginning, I promised we were going to talk about model predictive control. So why don't we do that now? And since some of our listeners and viewers may not be really familiar with it, why don't you try? Can you explain what it is?
Yeah, so you're asking for the 1 minute introduction to
Yeah, give it a
MPC.
try. Mhm.
So I would say there are a few ingredients, and
Mhm.
that's how things are usually presented. You start with some mathematical model of the system that you want to control. Okay,
Mhm.
that's essential. As you operate the system, you have some target
Mhm.
that is specified over some time horizon, and that's where you want the plant to go.
Mhm.
And then as a next step, you actually do the control computation. Namely, you use this model that I talked about, and you calculate what inputs do you need in the system uh, that then so that the system follows the prescribed trajectory.
Mhm.
And that's fine, but because of the disturbances and model error, etc., you implement only the first one of those input moves, and then you shift the horizon and you repeat the calculation. So
Mhm.
I would say it's a trajectory optimization, and you could see the same thing in economics or at some other discipline. Why were they interested in MPC and didn't follow their more standard technology? The big advantage of MPC is that in this formulation, as I described it, you can easily deal with complications which are showstoppers for other techniques, like multivariable system, constraints, nonlinearities. They're easily incorporated in MPC while they all require special version when you use other techniques.
All right. So before we go, I'm wondering if we can look back on your career and what would you say has made, the biggest impact, first on your direction and overall direction the field has taken. So,
I think for me, and we discussed that a bit before, I feel very strongly that the biggest impact has come from the people, and for me, for the people that I was fortunate to work with. And it's not just a statement. I follow those people and I keep in touch with them. And not all of them, but my former students and co-workers, and there are probably about
mhm,
85 PhD students and maybe 20,
mhm,
30 postdocs. Many have taken positions of major responsibility
mhm,
in academia or industry.